Welcome to Part 2 on sound insulation, where we will address Design Problem 11, Achieving Acoustic Privacy, specifically concerning apartment party walls. Upon completing this design problem, you will be able to understand sound transmission class ratings, evaluate wall acoustic performance, compare alternative partition constructions, and enhance occupant comfort and satisfaction. In our design scenario, a developer is building a multi-family residential building, requiring the party wall to achieve acoustic privacy. The minimum project requirement for the sound transmission class, or STC, is 55. The architect must evaluate wall assemblies to meet this acoustic requirement. Acoustic privacy matters because noise complaints are common in residential buildings, including conversations, television, music, and children's activities. Poor insulation leads to occupant dissatisfaction, chronic complaints, reduced property value, and expensive retrofits. STC is a single-number rating for airborne sound insulation in walls, floors, ceilings, and doors. An STC of 55, the typical target for party walls, means most speech is inaudible. The initial proposed wall assembly uses 92 mm metal studs, 16 mm gypsum board on each side, and mineral wool insulation, yielding a typical lab STC of 52. This fails the required STC 55 minimum by 3 points. The alternative assembly in Step 2 upgrades the sheathing to double 16 mm gypsum board on each side. This results in a Laboratory STC of 58, which satisfies the STC 55 requirement in a controlled lab setting. In Step 3, we consider field performance. Due to construction realities like electrical outlets, service penetrations, and poor sealing, field STC is typically 3 to 5 points lower than lab STC. Designers must include a safety margin. Checking the field performance in Step 4, we apply a typical 4-point reduction to the lab STC of 58, resulting in a predicted field STC of 54. This is marginal and high risk, as it may fail the required STC 55 minimum in reality. The improved design solution in Step 5 recommends a double stud wall with a structural break, mineral wool insulation, double gypsum board layers, and resilient perimeter sealing. This achieves a predicted field STC of 57 to 60, safely exceeding the STC 55 requirement. For execution, design recommendations include double stud walls and acoustic sealant at perimeters. Avoid mistakes such as back-to-back outlets, unsealed penetrations, continuous sealing plenums, and rigid structural connections. As a professional practice note, remember that occupants experience field performance, not laboratory performance. Focusing on detailing, sealing, and flanking control is often more important than just increasing gypsum board thickness. Key takeaways include that STC is the primary metric, residential projects target STC 50 to 55 plus, and double stud walls are highly reliable. The design checklist ensures the target STC is met, a safety margin is added, flanking paths are reviewed, and appropriate materials are specified.